Welcome viewers, in this video we will see the flip-flop conversion D flip-flop to JK flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, flip-flop conversion from D type to JK type. We know that flip-flop is a storage element. It will store 1 bit data. The flip-flop, the output, 2 stages available, present state, next state. So the next state output depends upon present state output as well as the input. So input, present state output will decide the next state output. This is the details about the flip-flop. Now we'll see the how to convert D flip-flop into JK flip-flop. First you will see the conversion table. So we are going to convert into D flip-flop into JK flip-flop. So first you will see the truth table of the JK flip-flop. J and K, 2 inputs available. Output, 2 stages, present state, next state. Present state Qn, next state Qn plus 1. So this Qn plus 1 depends upon our next state output depends upon present output Qn as well as the 2 inputs. So J, K and Qn will decide the Qn plus 1. J, K, Qn, 3 variable, there are 8 possibilities are available. 2 to the power 3, 8 possibilities. That is 0, 0. First 0, 0, 0, 1, 1, 0, 1, 1. For J and K 0, 0, here 2 possibilities, 0, 1. 0, 1, 2 possibilities, 1, 0, 1. 1, 0, 2 possibilities, 0, 1, 1, 1, like that. Right? So here both are 0, 2 possibilities, 0, 1. Right. So J0, K0 and Qn also 0 means the next state is same, no change. If J and K both are 0, 0 means no change in the next state of output. 0 means 0, 1 means 1, no change. Present state and next state both are same. If 0, 0, 1, J is 0, K equal to 1 means K means it is a normally it is called SR flip-flop. S means set, R means reset. If the reset input is 1 means it will reset the output. Reset means 0. Reset means it is reset to 0. For 0, 1 the present state is 0, next state also 0. 1 means it will make it to 0. Right? So 0, 1, 1 is J input, J means reset, it will reset the output to 0. 1, 0, suppose if it is 1, 0 means, this is 1 means J input, set. It will set the output as 1. Whatever may be, it will set the output as 1. If both are 1, J also 1, K also 1, toggle. Present state 0 means next state 1. Present state 1 means next state 0. So this is the nature of the JK flip-flop. Both the inputs are 0 means no change in the present state and next state. 0, 1 means reset the output to 0. 1, 0 means set the output to 1. 1, 1 means toggle 0 to 1, 1 to 0. Right. Now this is the truth table. Based on that we need to decide the D input, D flip-flop input. By giving the proper D flip-flop input, the D flip-flop will be converted into JK flip-flop. Right. For 0, 0 means what is the input? 1, 1. Present state is 1, next state is 1 means what is the input we need to decide. That can be done by the excitation table of D flip-flop. What is excitation table? Output. From the output we are checking the input. Truth table means from input we are checking what is the output. J input, K input, Qn, what is the output? That is truth table. The excitation table means the output. For example, present state 0, next state also 0 means what is the D input? We are checking the input, that is excitation table. So Qn, Qn plus 1. 2 variable, 4 combination. 0, 0, 0, 1, 1, 0, 1, 1. For present state is 0, next state also 0 means D input is 0. 0, 1 means 1. 1, 0 means 0. 1, 1 means 1. What is the nature of the D flip-flop? The input what we are giving, it will be reflected as a next state of flip-flop. It will not bother about the present state. The input what we are giving is available as a output. That is the nature of the flip-flop. So D0 means Qn also 0. Qn plus 1 means D also 1. So both are same. Right? It will not bother about present state. So that this D flip-flop is also used as a register. Register or counters we are using D flip-flop. Counters mean what the input we are giving, that same input will be available in the registers also, right? So D input is reflected as a next state of output without bother about the present state of output. Both are same. So based on that we can fill this table. D input 0 0, if we want 0 0, what is the value? D should be 0. See, 0 0 means D is 0. Here also one 0 0 is there. D is 0. 0 1 means 1. Here 0 1 is there, 1. Here also 0 1 is there, 1. 1 0 means 0. Here 1 0 means 0. 1 0 means 0. 1 1 means 1. Here 1 1 is there, 1. Here one more 1 1, 1. So now we decided the D input based on the excitation table. Now we need to find the logical expression for D input using the Karnaugh map. By using Karnaugh map we need to find logical expression for D input, and that should be implemented with the logic diagram. Now based on this we will see the Karnaugh map to find the logical expression for the D. So this is the K map available. The three inputs J, K, Qn. J is available vertically. K and Qn available horizontally. Right. So this J, one variable, two possibilities, 0, 1, J bar, J. K, Qn, two variable, four possibilities, 0, 0, 0, 1, 1, 1, 1, 0. We know that there is an interchange between third and fourth column. 0, 0 means K bar, Qn bar. 0, 1 means K bar, Qn. 1, 1 means K, Qn. 1, 0 means K, Qn bar. Now all these values are filled from the table, what we discussed, conversion table. We know that this is 0, 1, 2, 3, 4, 5, 6, 7. So these 8 variables are filled together. So there are 4 ones are available. So these 2 ones are combined together and these 2 ones are combined together, right and left. So these 2 ones while combining, we have to refer the corresponding first row and second row. J bar, J got cancelled. Then corresponding second column, K bar, Qn. So one input is K bar, Qn. While referring these 2 ones is available in the second row. So it is J. This J is there. Then corresponding first column and last column. First column K bar, Qn bar. Last column K, Qn bar. So this K bar got cancelled. Qn bar available commonly. So that Qn bar. J, Qn bar is another input. So the D equal to J, Qn bar plus K bar, Qn. Now we need to implement this logical expression in the logic diagram so that we can convert D flip-flop into JK flip-flop. Now we'll see the logic diagram. So this is the logic diagram available. It's a D flip-flop. D input, clock input, Qn output, Qn bar, complement of output. Right. What is the D input? We need to give J, Qn bar plus K bar, Qn. So here we need one AND gate. Here we need one AND gate and both are added by one OR gate. So here one OR gate is there, 2 AND gates are available. Right. For the first AND gate, J input is given. One more input is Qn bar. This Qn bar is available here. So Qn bar and J is given. Another AND gate, Qn is available here. Qn is connected and K bar. K bar is needed. So K input with NOT gate is connected. So it becomes K bar. So K bar, Qn, here J, Qn bar. So both are added together and given to the D flip-flop. So that this D flip-flop will be converted into JK flip-flop. Now we'll see some small description is available. In this type flip-flop conversion, J and K are the external inputs of the flip-flop where D is the actual input. So in the D flip-flop we need to give the D input, that is the actual input, but we are giving externally J and K as the input as a external input so that it will convert into JK flip-flop. The 8 combination can make by using the J, K and Qn that's shown in the table. The what we discussed conversion table, J, K, Qn is the 3 variable. So based on that 8 combinations are available. Thus D stated in terms of J, K and Qn. That is, what is D stated? D stated in terms of J, K and Qn. J, Qn bar plus K bar Qn. Right. So in this video we discuss how to convert D flip-flop into JK flip-flop. First we discuss the JK flip-flop truth table. Based on that we decided the D flip-flop input from the D flip-flop excitation table. Then we calculated the logical expression for D input. Then that is implemented with the logic diagram using D flip-flop. So the D flip-flop is converted into JK flip-flop. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.